Ever found yourself puzzled by the concept of square roots? Well, today we're going to unravel this mathematical mystery. Square roots might sound complicated, but they're actually quite straightforward. A square root of a number is a value that, when multiplied by itself, gives the original number. For instance, let's consider the number 4. What number times itself equals 4? The answer is 2, so we say the square root of 4 is 2. Similarly, if we think about the number 9, what number multiplied by itself gives us 9? The answer is 3. Hence, the square root of 9 is 3. It's like a mathematical mirror image, a number reflecting back on itself. It's a fascinating concept, isn't it? It's one of those things that make math so intriguing and complex. So in essence, square roots are numbers that produce a specific quantity when multiplied by themselves. Now that we've grasped the basic concept, how do we find the square root of a number? Let's start with the basics, shall we? Picture a square with each side measuring 4 units. The total area of this square would be 16 square units, right? So we say that the square root of 16 is 4. In the same way, if we have a square with each side measuring 5 units, the total area would be 25 square units. Therefore, the square root of 25 is 5. Simple, isn't it? But what if we want to find the square root of a non-perfect square like 15? That's where the long division method comes into play. Here's how it goes. First, we pair the digits from right to left. For 15, we can't form a pair, so we start with one digit, which is 5. Now we find a number whose square is less than or equal to 5. 2 fits the bill because 2 squared is 4. So we write 2 above the line and subtract 4 from 5, which gives us 1. Next, we bring down the next digit, which is 1, making the new number 11. We double the quotient, 2 in this case, and write it with a blank space on its right. Now we find a digit that, when multiplied with the number formed by the doubled quotient and this digit, gives a product less than or equal to 11. 3 fits here because 6 times 3 is 18, which is more than 11, so we try 2. 6 times 2 is 12, which is also more than 11, so we try 1. 6 times 1 is 6, which is less than 11. That's our digit. Subtract 6 from 11, and we get 5. Since there are no more digits to bring down, we stop here. So, the square root of 15 is approximately 3.1. This is just a brief overview. The long division method can be a bit tricky, but don't worry. With a bit of practice, it becomes second nature. Remember, practice makes perfect. The more you practice finding square roots, the better you'll get at it. You might be wondering, where do we use square roots in real life? Well, the answer is everywhere. Square roots, in fact, have a wide range of applications in various fields. They aren't just abstract mathematical concepts. They're tools we use to solve practical problems. Before we wrap up, let's quickly recap what we've learned about square roots. Square roots, as we've explored, are essentially the opposite of squaring a number. When we square a number, we multiply it by itself. Conversely, finding the square root means identifying which number, when multiplied by itself, gives us the original number. We also dove into the process of finding square roots. Remember, the perfect squares, 1, 4, 9, 16, and so on, are easy to work with. But for non-perfect squares, we use a method like long division or approximation to find the closest possible value. But why does all this matter? Square roots aren't just abstract mathematical concepts. They're practical too. We see them in architecture, in the distance formula in physics, and even in the statistical measure of standard deviation. And there you have it, a simple guide to understanding and calculating square roots. Keep practicing, and you'll master it in no time.